In this video, we're going to look at some great identity questions. And so, for starters, what we've got is without a calculator, we've got to find the following in terms of sine 36. Everything must boil down to sine 36. So let's just draw our little cast diagram. And so sine 324 is somewhere here in the fourth quadrant where sine is negative. So it's negative sine, and you're always saying how far back to 360, and it's just 36. And so there's your answer in terms of 36. So hopefully that one was pretty chilled. This one, cos 72, if you're in grade 11, you can shut your ears. You won't necessarily be able to do this, but if you're a matric watching this, you would have just seen this as double 36, and you can choose the double angle that involves sine. So that would have been your answer. Then prove this identity, and so just immediately looking at it, I'm seeing a couple of tans, so I'm getting excited about sine over cos. I'm also noticing that there's fractions, and so I'm going to have to be looking out for getting a lowest common denominator, and then going to the good Lord in prayer and hoping that I end up with cos squared. So let's see what happens. So 1 minus tan squared is going to be sine squared over cos squared over 1 plus tan squared, which is sine squared over cos squared. You could at this stage have said, I'm going to rather keep it all as tan and try bring it up from there, but I'm going to just head down this route. So on the bottom here, I'm needing to get an LCD because I've got two terms that are plussing. So it's going to be 1 minus sine squared theta over cos squared theta. And instead of writing this divide, because I hate multi-layers, I'm going to just write a divide symbol and then neaten up this. So because the LCD at the bottom here is cos squared, the 1 needs a cos squared, so it will become cos squared plus, and sine squared doesn't need a cos squared. Then in my next step, I'm trying to do things at the same time to save time in an exam so that I'm not writing my life history for the examiner. I'm going to tip and times, so I'm going to turn this divide into times. So this will go at the top now, and sine squared plus cos squared is just 1. When you do that, it looks visually so nice because you can cancel the cos squareds and you're just left with 1 minus sine squared, which is buzzing in your head as an identity, hopefully, that just becomes cos squared, which is your right-hand side, which is great. Then you have to use this answer you've just done to get the general solution of this massive mumbo-jumbo. And so what they're looking for with these type of follow-on questions is, can you see the link that it's the exact same question, except that any place that there was a theta, it's just become half x. And so that means that the answer that we got earlier just becomes that answer with a half x. And so I could say something like this. I've noticed that theta just became half x. And so this entire monstrosity here just becomes cos squared. And instead of writing theta, I'm just going to write half x. So that's what we've got here, equals a quarter. How do you get rid of the squared? You square root it. And when you square root something, you must always do plus minus. So it equals plus minus a half. Now when I do the general solution, it's going to be a little bit of a headache because you're actually going to be in all four quadrants. If I look where cos is positive, that's the first and fourth. If I look where cos is negative, that's the second and third. And so in essence, I'm in all of the quadrants. And so what I'm going to do, so that would be my normal step 1 is tick the quadrants. My normal step 2 will be to just get the reference angle by shifting cos of whatever that is, so half, and I get 60. Don't worry about the fact that it's half x yet. We'll put that in the general solution equations. And so how do I get in the first quadrant? it's just going to be the angle, so half x equals the reference angle plus K360. And that, I'm going to get rid of a half, I'm going to be timesing it by 2. And so that in essence will become 120 plus K720. How did I get into quadrant 2? The way that I normally get into quadrant 2 is 180 minus the reference angle plus K360. So that's 120. And if I double it, it will be 240 plus K720. How do I get into the third quadrant? It will be half x equals, the way I get into third quadrant is 180 plus. And again, I'm going to just double this answer. So this becomes 240. So if I double it, it's 480 plus K720. And then the fourth quadrant, how do I get in the fourth quadrant? It will normally be 360 minus the reference angle. And again, that's just 300. When you double it, it's 600 plus K720. And that is your arduous 4 general solutions, which is quite a unique case. But it was just because we had the issue of plus minus, which covered all 4 of the quadrants. I hope that you found that video helpful. If you did, please like it, subscribe to our channel, and share this with your friends. Thanks.